Hello, Coach Travis here with another calculus video. So in this problem, what we got is a question about the total displacement of a moving particle. So a particle is moving along a straight line with a velocity given by this function, and we want to find the net displacement of the particle when the particle is allowed to move basically 8 seconds, from time is equal to 0 to time is equal to 8. So over the time interval from 0 to 8, if the velocity function is given by this, what is the net displacement of the particle? So when it comes to these problems, there's two things to remember. There's displacement and there's distance. So displacement and distance are not quite the same thing, although they are related. And the other video I posted explains kind of the difference between the two. Happily for us, finding the displacement is a lot easier than finding the distance. So indeed, basically the net change theorem just completely finds displacement all for us. So essentially the net change theorem says that if you know the velocity of the function and you know the time interval, then the displacement is just the integral of the velocity over the time interval. So no problem whatsoever. So it's going to be the integral from 0 to 8 in this case, of negative 2t plus 5 dt. And so now it's just a matter of evaluating this definite integral, which, because of the fundamental theorem of calculus, is not too bad. So let's see here. So the antiderivative of negative 2t is going to be negative 2. The negative 2 is a constant, so it can stay there. And the unantiderivative of t is t squared. Oh, wait, not so fast. But you have to divide by 1/2, because when you use the power rule, the 2 is going to come down. And so if you just want to get t, then the antiderivative is going to be 1/2 t squared. And then an antiderivative of 5 with respect to t is just 5t. And that gets evaluated at 0 and at 8. And so, all right, well, let's simplify this a little bit before we plug in the numbers. Negative 2 times 1/2 makes negative 1. So this is just going to be negative t squared plus 5t. And that gets evaluated at 8 and at 0. And so, okay, so if I plug 8 in there, I get negative 64 plus 40, and then I have to subtract what I get when I put 0 in there. But it's not hard to see that when you put 0 in, you get 0. So we wind up with a negative 24. And that would be our final answer. And you might say, wait, does that make sense? Does it make sense for my answer to be negative? And the answer is yes. That's the difference between, or that's one of the differences between displacement and distance. So distance will not be negative. Distance can never be negative. But displacement can definitely be negative. Because, well, long story short, displacement is a vector, whereas distance is just a scalar, and it's always going to be a positive scalar. But sort of displacement tells you, how much did your position change altogether. And so what our answer tells us here is that our particles started 24 units to the left, or sorry, it ended 20 after it got done moving. At 8 seconds, it wound up 24 meters to the left of where it started. I mean, because if you think about the number line, Traditionally, moving to the right is positive and moving to the left is negative. So the fact that we got a negative number here just means that the particle ended up 24 units to the left of where it started. And that's what so displacement can be positive or negative. Like if the particle wound up to the right of where it started, then we would have had a positive answer. So anyway, the moral is that computing the displacement of a moving object, if you know the velocity, is a piece of cake. Using the net change theorem, you just integrate the velocity function over the time interval.